Hello everyone and welcome to Pentagon. Here's today's problem. We have a cube and a triangle MNH is constructed inside of the cube. We're given that M is the midpoint of segment AB, N is the center of face AFEG, and the area of the blue triangle MNH is 13 times the square root of 14. The question is, what is the side length of the cube? Please pause the video here if you'd like to try and solve this yourself. Alright, let's start by looking at the givens. We're given the area of a triangle and we're asked to find a side length. Might not be of that triangle, but there is a way to relate these. One of the few formulas that relates area and side length, especially when dealing with triangles, is called Heron's formula. Heron's formula. And Heron's formula states that the area of any triangle is equal to the square root of S times S minus A times S minus B times S minus C, where A, B, and C are the sides of the triangle, and S is the semi-perimeter. It's half the perimeter of the triangle. Now, we're given the area of this blue triangle, and using this, we can somehow find the side lengths of the triangle, and that could help us to find the side length of the cube. To do this, we'll look at the other two givens. Our first given is that M is the midpoint of AB. Well, I think it would be helpful to use a variable for the side length of the cube, so let's call it x. Now, since M is the midpoint, we know that midpoints divide a segment into two congruent parts, and therefore AM and MB are both going to be a half of x. Now, we also know that all the angles in a square are right angles. So, I don't know if you can tell, but there's a right angle, and MBH is actually a right triangle that is stuck on the side of the cube, that's stuck on face AFHB. So if I pull this triangle out and draw it here, it might be clearer to see. So this is B, this is M, and this is H. And that's the right angle. So I've pulled out triangle MBH and drawn it out here. Now we said that BH is x and MB was a half of x. Alright, now we know that MH is the side of the blue triangle, so we can use the Pythagorean theorem here and find MH in terms of x. So using the Pythagorean theorem, we can say a half of x squared plus x squared, those are the two legs, it's going to equal the hypotenuse squared, which is MH. So this is going to equal MH squared. Right, if we expand the left side, we get x squared over 4 plus x squared is equal to MH squared. Now if we simplify the left-hand side, we get 3x squared over 4 equals mh squared. Right, and now finally to solve for mh, we'll take the square root of both sides. Oops, that should be a square there. And we get that mh is equal to x times the square root of 3 over 2. Alright, and this is going to be useful. We will need this. Alright, because we're going to need to use this to plug it back into Heron's formula. Alright, now let's do a similar thing with one of the other sides of the triangle. Let's take the side NH. Now, we've said that N is the center of the top face. This must mean that the diagonal of the square is going to be cut in two, right at the center, so N is naturally going to be the midpoint of the diagonal. Well, in a square, the ratio of the sides to the diagonal is x to x radical 2. So if n divides the diagonal of length x radical 2 into a half, well then each half of the diagonal is going to be x root 2 over 2. And for our purposes, we're going to apply that to Fn. Alright? Now, the sideways face, or shall we say the back face, face FEDH, contains an edge, FH, that is perpendicular to every segment in the top face. Because we have a vertical face that is touching a horizontal face, so naturally these two faces are going to be perpendicular, which means this over here is going to be a right angle. So as you can see, we've made another right triangle. This time it's HFN. So now let me pull this triangle out. For you to see. Alright, and this is H, this is F, this is N, and that's the right angle. Alright, now FH is going to be X, since that's the side length of the cube. Fn is X radical 2 over 2, since it's a half of the diagonal. And now we can use the Pythagorean theorem once again to solve for NH. So we'll say that X root 2 over 2 squared plus X squared is equal to NH squared. Now if we expand the left hand side, when we remove the brackets, we'll get 2x squared over 4 plus x squared is equal to nh squared. And 2x squared over 4 is just really equal to x squared over 2. Alright. Now, let's simplify the left-hand side. And when we do that, we get 3x squared over 2 equals nh squared. And when we take the square root of both sides, we get that nh is equal to x times radical 3 over radical 2. And we want to rationalize the denominator. We don't want there to be a square root down there. So we'll multiply the numerator and denominator by radical 2. And we'll get that this is equal to x times the square root of 6 over 2. Right, and here's another bit of information that we need to save. Alright, now let's go back to the last side. And that side is going to be MH. Once again, let's construct a right triangle. We already have AM, which is x over 2. And now we're going to draw in this half diagonal again. And we said before that the measure of this was x radical 2 over 2. And over here, this angle MAN, is a right angle. So I'll draw that here. Right. Now, if I draw it here, this is M, this is A, and this is N. Now we said that AM is x over 2, and AN was x root 2 over 2. Alright, and now let's use the Pythagorean theorem once again. We'll have that x radical 2 over 2 squared plus x over 2 squared is equal to mn squared. Alright, let's expand the right hand side. We will get 2x squared over 4 plus x squared over 4 is equal to mn squared. Oh, my apologies. The length of MH is not x root 3 over 4. It's x root 5 over 4. Over 2. Alright. Back to Mn. This one results in 3x squared over 4, which equals Mn squared. And when we take the square root of both sides, this time we actually get Mn equals x radical 3 over 2. Alright. Now, we have the side lengths of the triangle. And now we're ready to plug them into Heron's formula. So, let me just erase the computations that we've done. For more space. Right. And let's write our newly derived information at the top. So we have that MH is equal to x root 5 over 2. We have that NH is equal to x root 6 over 2. And finally, we have that Mn is equal to x root 3 over 2. Alright. Now we can erase these. Alright, now, the first thing we need to do is calculate the semi-perimeter. To do that, we add up all the lengths of the sides, and then we divide by 2. So, the semi-perimeter is going to equal MH plus NH plus Mn over 2. Now let's plug our values in. Mn is x root 5 over 2. NH is x root 6 over 2. And Mn is x root 3 over 2. And this is all over 2. Alright. Now once we've simplified this further, this will be equal to x times root 5 plus root 6 plus root 3 all over 4. This is the semi-perimeter. Alright, now we'll use this as well as our side lengths and plug them into Heron's formula, and from that we can solve for x, which is the side length of the cube. This might look a bit ugly in the beginning, but I promise you it turns out beautiful in the end. Alright, so we have that the area of triangle MNH, so the area is equal to square root of, and first we'll have the semi-perimeter, so that's x times root 5, plus root 6 plus root 3 all over 4. And now we want to start subtracting the sides and seeing what we get. Alright? Well, let's take the semi-perimeter and subtract from MH. Well, subtract MH from the semi-perimeter. When we do that, we get x times, in brackets, root 6 minus root 5 plus root 3 all over 4. And if we do this with the other two sides, we'll get x times root 5 minus root 6 plus root 3 all over 4, and x times, in brackets, root 5 plus root 6 minus root 3 all over 4. Now you'll notice that in each factor there is a factor of x over 4 in there. So if we pull that factor out, just erase these. Right. If we pull that factor out, we'll get inside this giant square root our common factor will come together and we'll get, well, there are 4 x's being multiplied together, so that's x to the 4th over 4 4's being multiplied together, so that's 4 to the 4th. And the rest are simply our square roots, our radicals. So that's going to be root 5 plus root 6 plus root 3 times root 6 minus root 5 plus root 3 times root 5 minus root 6 plus root 3, and finally times root 5 plus root 6 minus root 3. Alright, now this x to the 4th over 4 to the 4th. Since both are being raised to the 4th power, this is going to be a perfect square. So we can take it out of the square root And we can say that we can simplify this into the area of x squared over 4 squared, which is just 16, times this massive square root of these 4 factors. Now let's try multiplying these factors in pairs, and let's see the result. Right? First, let's take these 2 factors and multiply each factor together to expand this. Alright, so first, this is going to turn out to be one giant expression. So first we do root 5 times root 6. Well, that's just root 30. Next, root 5 times negative root 5 is the negative square root of 25, which is just 5, so minus 5. Alright. Then root 5 times root 3, which is root 15. Right, next, root 6 times root 6 is root 36, or just 6. Root 6 times negative root 5 is negative square root of 30. And root 6 times root 3 is root 18. Alright, now on to the last 3 pairs of factors. Root 3 times root 6 is root 18. Root 3 times negative root 5 is negative root 15. And root 3 times root 3 is root 9, or just 3. Alright, and that was one pair of factors. Time to do the other pair. Alright. Here we go. Alright. First we'll start with root 5 and multiply by each of these factors. So root 5 times root 5 is 5. Root 5 times root 6 is root 30. Root 5 times negative root 3 is negative root 18. Negative root 6 times root 5 is negative root 30. Negative root 6 times root 6 is, well, it's negative 6. And next, negative root 6 times negative root 3 is a positive root 18. Right. I'm sorry, this should be positive, not negative. Alright. Now, lastly, multiplications with this root 3. Root 3 times root 5 is root 15. Root 3 times root 6 is a positive root 18. And finally, root 3 times negative root 3 is minus 3. Alright. Just one more apology. That is indeed negative. It is a negative root 15. Right. Now, if you look closely, you'll notice something interesting. In each of these factors, we have a lot of terms cancelling out. So, for example, let's take a look at the first, all the numbers in the first brackets. Well, there's a 30, and there's a negative root 30. There's a 15, and there's a negative root 15. These cancel out. Same thing happens in the second brackets. There's a root 30, and there's a negative root 30. There's a negative root 15, and there's a positive root 15. So once the dust has settled, you get the area is equal to x squared over 16 times, well, if we simplify the first bracket, we are going to get 2 times root 18 plus 4. And if we simplify the second bracket, we're going to get 2 times root 18 minus 4. Well, this should look familiar. This is a difference of perfect squares. So we can simplify this even further. We can say that the area is equal to x squared over 16 times, now 2 radical 18 squared is 18 times 4, or 72. And 4 squared is just 16. And this is equal to x squared over 16, and 72 minus 16 is 56. Now, do not forget that we had this area defined. We were given that the area of triangle MNH is 13 radical 14. So this is all equal to 13 radical 14. All right. So now we have x squared times 16, and in this 56 we have two factors of 4 and 14. Since 4 is a perfect square, we can pull it out of the square root, and we'll get 2 times radical 14. And this is equal to 13 radical 14. Well, we have radical 14 on both sides, so they just cancel out. And now we have x squared over 8, since these also simplify, is equal to 13. When we multiply both sides by 8, we get that x squared is equal to 104. And finally, when we square root both sides, since we only need the positive value, since we're looking for a side length, we get that x is equal to the square root of 104, or that x is equal to 2 radical 26. And this is our answer. Thank you for watching this video. If you liked it, please consider subscribing to our channel. Thank you all, and I will see you in the next video.